micron size or one micrometer size we take, there is a challenge where your object cannot be achieving your exact design of which we are supporting at. If you see the support systems which are being very complicated structures, and which this technique is very complicated if you consider these points of tissue engineering is concerned. So you have the techniques, but the design strategies are very, very important, because in 3D printing, only material you have, only the technique you have, but the designer has to sit. Designer has to develop a scaffold, which is very, very important. And this particular thing, when you are applying towards your any of your applications, for example, if you go and you are getting into a ocular, if you say eye related, it is going into a fluid area. So you have to predefine the material, you have to predefine your design, you have to predefine your printing dynamics, you have to predefine your complete fabrication planning of your part when you are designing the part itself. Though the scaffolds, material, biofabricate, so there are so many constraints, but designer should know that if I design this, whether this design can be printable in 3D printing or any other technique, whether it has to be printed with this particular material. You have to consider the material perspective. You have to consider the constraints on the biofabrications, and then we have the computational design, and then we also should validate the final or a functional area where this final 3D printed scaffold is being implemented. In this perspective, you have to design your scaffolds, and you have to have majorly, and right now available with these three, what we call as CAT, computer aided tissue engineering, is right now available, where people started working on the tissue engineering, on the computer aided design engineering, aided tissue engineering, which is called popularly called as CATE, which I guess, which I have the knowledge is, there are some three company design companies like Autodesk or Maya are related to two to three other companies are already providing in SolidWorks, and they are giving as an add-on for this package. Computer tissue engineering is one particular package is being offered these days, and then tissue engineering scaffolds, CAD geometry development, those developments people, because of the use of the data or various tissue engineering scaffolds being developed in the various geometry, CAD geometry developments, scaffolds are focusedly developed, and then there is availability of geometry right now, whatever I'm talking, but in some of the softwares already these scaffoldings design geometries are available, where you can plug and play into this one and then develop this scaffoldings, so that the design strategies or design issues which you are going to face during the 3D printing of that particular geometry can be focused, and then you can achieve that particular issues which may you may face in future. And then computer assisted optimization of TV tissue engineering scaffolds. This is one more point. This computer assisted optimization of tissue engineering scaffolds is where you get the assistance. As I told you, you get the geometries available, and how you use the geometries inside for development of the scaffold is one more strategy, where the mechanical guy plays very crucial role for helping to the biomedical guy. But biomedical guy knows about the tissues, how they work, what is their growth, and what is their future plans and everything. He has to take the assistance from the mechanical guy, or that the 3D printed scaffolds. There are bioprinting, as CATI is one of the programming where they can use directly there, and then they can 3D print the scaffolds, optimization of assisted optimization of 3D printed scaffolds. So these are the main strategies which you have to use, especially CAT-A or the scaffold series geometries which has to be, and then computer assisted optimization. What I am talking about is whether that optimization helps for the complete final goal of printing the tissue engineering scaffolds is one of the final goal which we take it up. So computer assisted optimization helps the TE scaffolds for getting that particular area being printed or being given an outcome for that particular TE scaffolds, which will help. So this is the this is a data driven software which will help the people to work on the development of T means tissue engineering, and then which assists for it may be printed or may not be printed, or errors which being prompted from the softwares. So this is the strategies which you have to use for the 3D printed scaffolds. Coming to the materials, so the design I have discussed, and then the regular manufacturing of 3D printing techniques I have discussed, and I'm right now working into the biomaterials used for TE scaffolds of the 3D printing. So to briefly divide which materials we are using and which what is the material whatever we talk about the polymers we are using, and then people know about, I guess the bioprintical people will be knowing about more on this particular thing, especially if you see the natural polymers, synthetic polymers, hydrogels. And these three, if you see the natural polymers, we have the hydroxyapatite, and coming to synthetic polymers, we have PCL, and the natural polymers, we have various biomedical materials, biocompatible natural materials like gelatin being used for the and collagens are also being used for various needs. So these biomaterials are used for the 3D printing in our regular 3D printing printers with some of the companies. I guess in this series only there are some company owners who have discussed about this 3D printing technology. So these polymers are being used. And just to summarize the polymer scaffold which is being used, and what is the printing method and what are the applications, this is a listed technique being being used. If you see the polymer scaffold, chitosan or rhino. I'm very poor in this spelling of these things. Fungi, and then bone regeneration, which we use for that particular thing. Method can be used. Any of the methods can be used. And then PCL, we have the direct printing. FDM, we can do PCL alginated based hydrogel. We can use extrusion, and then bone tissue engineering, PCL/PLA, bio extrusion tissue engineering, which we our application is. Coming to PCL and chitosan, we use FDM. So these listed printing methods are right now followed, and these applications are being used or they are already printing it. So this is a complete overview related to 3D printing. And then PCL with castle oil is one more addition in the bone tissue engineering. And then PCL with HA. And then if you go with FDM versus FDM versus indirect 3D printing, extrusion, FDM, extrusion, PLA, cellulose. So these materials, whatever I'm talking about, these materials which we use for 3D printing, especially in the tissue engineering, bone tissue engineering, maximum if you see the column from in the middle, FDM and then extrusion are very much famously used, and this 3D printing technology is able to help the and achieve the outputs from this from this complete FDM and extrusion related 3D printing approach, which being used for the especially bone regeneration tissue and then other tendon bone related activities. Apart from this, there are certain specific applications. If you see, if I talk about the hydroxy update, or polylacto co-glycolic acid, or polylactic caprolactone, or ABS, or acrylobutadiene, or polyethylene glycol dichlorate, and then cellularized structures. And then apart from this, we do have metallized gelatin and various materials I have listed on this. So just not getting into deep on each and everything. I'm just focused on your polymer scaffold and how the 3D printing is helpful, and the method of 3D printing. Hot melt extrusion is one more thing which is being used for the tissue generation, especially for PLCL and then DECM. This is one material which is being DECM. I don't remember what ECM expansion is. Okay, DECM is gelatin only, I believe. So, okay, that material. And apart from this, if you see the alginate material, which is used for the kidney application, again, it is again extrusion. If you look Google, we have the printing of kidney being used in the extrusion technology only. Very famous video will be running in Google about the kidney 3D printing. And then coming to the cartilage extrusion again. So various whatever listed on the left side, you see gelatin and then silk fabricant related to the skin. It's against extrusion stereolithography, and then extrusion stereolithography, DLP, DIW, and then inkjet. So whatever I'm talking about, the materials or scaffolds which are being shown in the left side, these all collagens or alginate materials, alligate, I'm spelling, I'm not sure in the bio how you talk about, and then cellulose nanocrystals and PLGA, especially for the liver tissues. There is a company which is working on this liver development, and they are trying to develop a tissue related to liver on 3D printing of the liver to address the problem of liver replacements. And then some companies are working on the kidney related. In India also, people are trying to explore and people are trying to get the data and try to print these particular gels as per the design or the scaffoldings or various needs. Especially if I go in deep of the technologies or materials, whatever we discuss, apart from this polymers like natural or extrusion or natural polymers or synthetic polymers or hydrogens, whatever we are seeing in this, the major advantage or people we see at is the 3D printing extrusion based layering, layer by layer approach to form the object as per the design of this scaffold, which is playing a very crucial role for development of the tissue. So if you see apart from the polymers, there are certain ceramic scaffolds where the ceramics and polymers and then printing method. This is very now with the addition of polymer or without the addition of polymer, ceramics will be printed. If you see the ceramics, whatever I see like hydroxyapatite or PCL or TCP, that is tricalcium phosphate, these materials, if you see one line left side ceramics and then polymers without mixing polymers also, you have the methods available right now for advancing your research related to the 3D printing in the biomedical engineering, also for the development of 3D printing of the tissues especially. So in the left side, there are certain issues being faced when they are mixing with the phosphoric with collagens, which is very challenging. And if you see ceramics like titanium, which is a metal, actually we have given that is laser beam melting, and which is being used in our facility. Also we have a laser beam machine which we are printing this 3D printed structures for various needs. It may be for your scaffolds also, for any of the research, not for direct implantation, but still we have a pure titanium also available with us, where we are printing with certain mixing of the materials, and then we are getting the outputs. So in these all left side ceramics being mixed with the polymers, we get this final output, and then the applications or methods whatever we are seeing. And all methods whatever we see in the methods being seen in the right side, again extrusion method, and then plays very crucial role when you are combining with the ceramic with the polymers. So inkjet and then DLP, FDM, a laser based, and then laser assisted gelling. If you see, this laser assisted gelling is one particular thing which is used for the silica and carbon calcium carbide materials, which is very silica based. Silica majorly it works with the laser assisted gelling, but properties is one challenge which people are facing, but still they are able to work on it, and then they are working on this laser assisted with the silica and then calcium carbide material, which the ceramic scaffolds are being generated, and then they are assisting. So so to move ahead, why this many things all are available? What is happening right now in the market? To discuss with you, I just listed some of the advanced techniques, whatever it is, if you may consider what is happening in the market, what are the advanced things that are being used, especially nervous tissues. Nervous tissues is one of the famous, so not of the famous, I'm not sure to use the word of famous. These advanced 3D printing tissue engineering constructs, which they are taking as for the central nervous system and then peripheral nervous system, which the tissues may be repaired. So there are vitro models of brain are being developed in the microchannels with the collagens using needles and 3D printed frame. Especially they are working on the mouse brain cells or cultured on the collagens and then microchannels, which resulted in the regeneration of the brain microvasculate. This experiment has shown that model of the brain blood barrier can be used for pathological and psychological tests and applications of drug delivery, tissue generation, tissue engineering being used in the nervous tissues. This is the where the 3D printing is playing very crucial role with you compared to the regular manufacturing or a conventional method of doing the business in 3D in biotechnology. This technology, especially the nervous tissue generation, if you see these tests, the drug delivery or the tissue generation or a tissue engineering perspective, this is very, very big advancement. People are so much working with it. And then ocular tissues. This is one being project being having thousands of money being involved. Birac funds, various people are funding on this, where you have this ophthalmology being involved and you have the issues related to the construction of 3D retina. If you lose retina completely, your life will be blind and you are not able to do it. If this breakthrough happens, because there are some R&D company, R&D big professors from biotechnologies, from IITs, NITs, especially IITs in Hyderabad or Tirupati or wherever people they are looking at for the reconstruction of the complete 3D retina, which is being right now worked with various hospitals across Hyderabad or various across Delhi, names and everything. They are reconstructing of the 3D retina, which is they are identified and they are working at. And then fabrication of complete tissue engineered corneal scaffold made of collagen based bio containing encapsulated coronal keratocytes with keratinocytes, which they call. This is one more area of the ocular tissue being generated in tissue engineering, where the advanced 3D printed TE constructs, where they are working at for the complete ocular tissues, which they are being, working at, and then they are producing this the ocular tissues. Coming to the ear, this is one more advancement where the computer aided design has been used to create the human ear, where we have this scanning being done. That scan can be taken as a 3D scan file, can be taken into the design, and then hydrogel matrix containing the cells can be layered layer upon layer, layer upon layer to develop this layer upon layer to build that particular what I say the complete area can be 3D printed, and then addition of the silver nanoparticles being used for the printing, which helps in additions for the development of the human ear, which there are various techniques which they are using, but whatever, especially for the tissue engineering constructs, ear is one which is being used for cartilage issues are being used for this one. And this is very, very other advancement which is happening from last 7 to 8 years, where the scaffolds, the kidney is being 3D printed with the material with the scaffolds from PEGDA with the addition of sodium alliginate and alliginate and then calcium sulfate were tested. And after the fabrication, scaffolds were cross-linked with the UV light and subsequent human embryonic kidney cells were cultured. It was shown the mentioned composite materials are character. This I have copied from one of the paper. I'm very much clear to be in this session that I have taken it from one of the paper. And then the extrusion-based 3D printing was applied for generation of human kidney organoids, which is a simple version. Completely the organoid, which is the word being used, is a living organ produced in vitro. So this kidney advancement will break the complete systems where people are waiting for the kidney replacements. So this advancement in 3D printing, only 3D printing can do this particular reproduction of the kidney. So they have already started working on this, and 3D advanced 3D printing constraints. This is one of the major advancement. Skin, everybody knows. I don't know if I can play that. There is one video which where the American soldiers are injured, where and then their skin is being damaged. The skin cells are layered one by layer upon layer, layer upon layer to make the complete dermis restructured, and then they get this object coming out. Layer being formed on the skin so that the skin can be restored to the actual state. So there are gels which are available right now. Skin gels, sometimes they take from the same human person to take the skin cells and then they layer upon layer. If they have a groove or the damage being no damage being there, where people may have the issues related to it. So basic layer and then epidermis layer. There is certain 3D printing what verbs they use for this 3D printing of the constraints. Bone and cartilage tissue engineering is one more advancement where the bone is being 3D printed with the hydroxy update. At 3D Ceram company is being one of the famous company from France, which they are printing with hydroxy update. And then they some bones sometimes regenerative procedures are being used for example, our damage of knee or bone. They want to print with the hydroxyapatite bone powder, and then they want to make that particular bone being printed, and then they want to make it as a live bone after a period of time by giving you various scaffolding structures, and then various structures related to the cells that, and also make the cells to grow. And then scaffolds, which are the major criteria in the bone engineering, especially if you see the cells growth which is being adhered and migrate and then differentiate into the orthogenesis, which will help to grow the complete organ, helps to, because of the scaffold the cells will grow, regrow, regenerate and everything. So these cells which are being helped because of the T constructs only, those gets regenerated. So this is the advancement of various people, whatever we see on people who are working on this, various people who work various you see people especially if you go to the TE related tissue engineering related aspects. So to just divert from the topics of this advanced 3D printing constraints, we do have the other we do have the dental related. I think some speaker has already covered this particular point of dental related things. But if you see the major advantages or disadvantages which we observe in the tissue engineering perspective, and in our case, if you say uh, this product has very costly infrastructure, which is very no. We need to have a robust laboratory, or we need to have a very high research institutes which should have a class certification, and then you have to have a hospital and research institute collaborated to it, which is becoming a very big challenge. So this 3D printing, maybe it is in advanced stage, but these are able to be achieved only because if you have certain high level infrastructure being available. First and foremost is software, which you develop your designs, and then should have a very a robust output, and then you have to have a high computer stations which will work on the cultures, and then should have a high processing speeds. And apart from that, we should have a high quality 3D printer, and then 3D printer needs to have a certification, and those 3D printer manufacturers also need to have a material certification, machine certification, and also the process certification. So these certifications make the advancement of 3D printing of tissue engineering at a hold, and people are still slowly adopting it. But the funding agencies have started identifying the advantages, and then collaboration between the engineerings and doctors needs to be there in this, which is the biggest challenge which is being faced. And then if the agencies are related to the engineering, and then if the agencies are related to the doctors, if those two combine together, and the complete printing centers or then everything needs to come. And the biggest challenge in this tissue engineering constraint is the focus of identifying the engineer with a medical knowledge is becoming a challenge. So there, whoever has the design perspective, they should also have a knowledge of how the tissue grows and what is the focus. This biotechnology people or biomedical people knows about these things, which they should focus on. They are having the demand, but the infrastructure availability is less. And then skill manpower for this particular thing, which they need to have both ways, is very challenging. And apart from this, there are so many other perspectives which people think about it. If you see, uh, when we create a final outcome and we get a scaffold being, in vitro tested, and you get everything, we have a very big, and there is a very, what we say, completely. There is no particular guideline document, what we call it as. We are not having a clear guideline document which helps these people to work on it, and then uh, which helps the people to work on and how their research is generated, whether it can be commercialized or if this can be used in the market. See, commercialization angle is very less realized, and people are not having any final outcome, or else after printing it there is no implementing agency which NCAM is working with Cedesco to identify certain parameters which will help for the final produced products. And also, if you see the biggest drawback, 3D printing plus TE scaffolds, there is a lack of standardized terminology also in this field, where the terminology people doesn't understand, or else if you develop the terminology also, that certification also becoming a very big challenge, which is having a very big issue which we are facing at. And patience, and end of the day you have to perform on the patient also should accept your tissue engineered material. And there is a big challenge where you have the availability of patients, and then quality of their lives. And after doing it, cultivation of the TE, tissue engineered constructs, how the life of the patient. And there are no certain what we call it as certain guidelines, or advanced techniques, or these things. And there is some small constraint. We call as 3D printed, but still there is a one more point where we have 4D. 4D is becoming a challenge for us, where we have this 4D is requirement for tissue engineering, because your structures are so complicated. You need to have a 4D printing also. But with the constraint of these things, 4D is becoming very challenging, and people are not able to get this one. And mechanical stabilization of the constructs is one more challenge which we are facing. I have not listed it in the PPT, but this is one more point where the mechanical constraints are being becoming very challenging for getting into this. And to summarize all these things, so I have discussed various points related to 3D scaffolding and 3D printing techniques and materials which are being there in the tissue engineering, and then 3D constraints, advanced 3D printing constraints, and we have discussed various needs in this one. So to summarize all this, completely 3D printed implants or 3D printing, which is happening right now. There is a one more angle where 3D printing is growing, is the advanced solutions which are being used just to have solutions where to give you a small to give you a small solution. There is one startup working in NCAM which is having this silk based material which is being manufactured with local silk material. They are doing a lot of efforts. We appreciate their efforts. And then these plates, whatever you are seeing, are now being manufactured, which will be a biocompatible. You get that material mixed in the body after a few days. So which is being right now researched in camp on this one. We are happy to fund them also for certain needs. So ownership doesn't lie with NCAM. Ownership lies with the inventor. They are working very hard, and then they are developing the solutions with their these things. So this is how the complete processing happens. So just to have, and I did not edit this one, implant design and approvals, and then additive manufacturing DMLS I have given. The process how it happens in even in this, if you see the image processing is this is the round one process which we have for the manufacturing of implant. Coming to the tissue engineering perspective, process is almost same, but the designing happens here. You don't have CBCT design, CBCT which comes for the tissue. We design it, and then the first part, if you see one for step one, step two, here the designer has to see. I have given you in these slides. Designer has to see this one, and then this manufacturing happens, and then sterile packing, dispatching. This is the procedure what we regularly follow. So this is a different DICOM processing, but this is different for us when compared to the tissue engineering. But just to see the other applications in 3D printing, these are the applications which we have in the surgical guides, braces, splints. And just want to show you this nose and ear. These are the printed 3D printed particles, which are processes which can be replaced using these biomedical gels, which I have told you. So in bioprinting in the right side, just to see the customized processes which I have discussed in the previous slides, just want to show the customized processes. If you see this one, these custom processes, this is the scaffolds being printed, and these are the scaffold like ear and nose. Side by side you can see, and then bioprinting of the kidney. This is one more thing, and this upper one is the implant model which is used for the cranial related activity. So for your sake, these three whatever I am showing in the downer line are the applications which are correlated for your final tissue engineering helps on this one. So like this, we do have certain cases which are involved with us. If you see this one, this is the one of the cranioplasty case. There is a case where the material has been chipped off. Their brain is accident case. We have restored it, and then we have 3D printed it, and then it's face safe now in the patient, and now she's fine, doing well. So this and in this we see, just why I have kept this one is there are some scaffolding or tissue engineering being kept at this particular area, jaw above area. You see there is a chance of getting this bone being regenerated at that particular area. So to see various, this one of the technique micro this is during the COVID we had certain cases like black fungus cases. People, a lot of people know about this particular fungal infection where we do work for this, and then tissue engineering is also playing very crucial role where we need to have certain spaces where we take the printing being happening, where we observe this cartilage to be structured, and then we do various methods for taking this cases which we work on the various macular fungus cases. So these are live cases which we have worked on it. So I guess Venkatesh, am I on time? Venkatesh.
Good evening, sir. This is Ajay Kumar, the coordinator for the FDP. Venkatesh has some network issues, sir.
Okay, could you able to, am I in time? Can we have questions on
Yes,
this?
sir. I request the participants, if you have any doubts, please use the chat box or unmute and you can ask the questions to Rakesh sir straight. Rakesh sir, I have one question.
Yeah.
Probably. Sir, what is the stage of metal additive manufacturing in India, sir?
The metal additive manufacturing, we have the powders being developed at our place. We are already printing the titanium implants. Whatever I'm showing in the previous cases, we have printed those particular implants in our 3D printing only.
Yes, sir. Even for one project, we had used this Ti6 for a medical grade alloy, and we have got some scaffold, a metal additive manufacturing based process only. What about
Okay.
the rest of the materials, sir? Rest of the metals? When we can expect like aluminum or maybe a magnesium? That
No,
diversity that diversity is required. When we can expect in India?
magnesium, we can't do it because of the way the laser additive manufacturing processes. Magnesium is a big challenge now because magnesium has high electric conductivity. Printing of magnesium is becoming a challenge right now. But right now, whatever we see, which is a biocompatible is neutral is Ti64 only. Titanium 64 is being used hugely across various entities. And then some people are still working at SS316L, stainless steel C316L. They are trying for, no, where there is no corrosion involved. They are trying with SS, and also cobalt chrome is regularly used for our teeth structures. The coping happens on particular teeth, and then they are using the base structure is for the cobalt chromium only.
Okay, sir.
Sir, I have one doubt, sir, actually.
Yes, sir, please.
Sir, you said that you're developing the powders at your place, right?
Yeah.
But sir, when I approached the NCAM center, sir, that metal additive manufacturing machine is for particular materials only. They cannot customize because they cannot go for other materials. The same answer I got.
Which material you have asked, sir?
Means at least means other materials other than whatever the inbuilt materials are there, no, sir?
First thing what we tell is try to get the powder from the powder manufacturer. We have a powder manufacturer in our place. If you can get powder getting manufactured, then we have the machine available. But machine availability in the sense, see, our machine is booked for 1 month, 1.5 months for various needs. If you can wait, then we can get the nearby parameters because we have to develop parameters for your new material. We develop the materials and those materials, nearby parameters we develop and then we give the prints and we have to go for the testings.
Okay, sir. How much amount of material may be required? A minimum quantity, like for
Minimum 4 kgs, sir, because we have to load the complete cabin.
4 kgs, sir. Okay.
We are getting new materials from where in Odisha. I don't know when you have approached us, but definitely there is a chance for you.
Sir, I didn't get, sir.
I don't know when you have reached NCAM, but there is a clear chances now because titanium only we are running right now. New related materials, nearby materials we are taking up, but not the completely a diversified material which doesn't have any parameter nearby. For example, you get some magnesium material. Magnesium we can't accept because what happens is magnesium is overreactive to the electrical thing. We have only one material that is ALS at 10 mg, which we are running regularly here. Aluminum based alloy that is running nearby. If you want to change the magnesium 0.6, you want to take like 6 mg, you want to take, you can take 5 mg or 4 mg change, and then we can print it here. We can take it from the manufacturer called Matrix Nano. If you ask them, they will give the different combination and then we can develop the parameters. But this is a bit lengthy process, you know. What happens is you could that particular thing we have to ask the OEM for parameters, nearby parameters. Those parameters we start print. First 2 layers we have to see print it and then see if we get any issues. Then we have to redefine the powder molecules and then recheck that powder molecules whether any foreign bodies are there, any issues are there. So on those issues we rework on this particular thing.
Okay, sir, can you please suggest the other materials, sir, like so that
You can send me a mail. I'll ask my team to work because things are very busy at NCAM because a lot of R&D happens and people are already printing will be in pipeline. So you can put a request. I'll ask my team to look into it. Okay.
Okay, sir. Okay, thank you, sir. Thank you very much.
Any other questions?
Sir, what are the peak materials that we can apply for the engineering application, sir?
Peak or PEC you're telling? Peak, alter. There are many materials in
Sir?
In peak is a specular material, polyethylene ether ketone, right? That material itself is available in 3D printing. Peak, PEEK.
Sir, it is available in NCAM, sir?
Not in NCAM. NCAM doesn't deal with peak. NCAM, I think NTTF Bangalore has the peak. PEEK.
Okay, sir. Thank you, sir.
Yeah. Any other questions?
Dear participants, if you have any other questions, please rise, unmute yourself and ask the questions. Sir will clarify the doubts.
Sir, what is the name, sir? Can you spell it again, sir? NTTF, sir?
NTTF Bangalore.
Okay, sir. It especially deals with the 3D printing, sir?
Yeah, they are specifically for 3D printing.
Okay, sir.
Any other questions? Then shall we wind up, sir? Ajay, sir.
Sir, okay, sir. Thank you very much for the wonderful session, sir.
Okay. Thank you, sir. Thank you very much.
Dear participants, please stay back. Examination you can attempt in the as assessment you can finish in the ATAL portal by logging into the ATAL portal with your credentials. Later we will have the validatory function exactly at 7:30. It lasts for only half an hour.
Excuse me, sir.
Sir, please tell me,
Ajay,
sir.
Ajay, sir. I have done that test and feedback, sir. So can I leave, sir?
No, no, sir. Sir, validity is there. We have to take a snapshot of all the people with video on that I have to upload into the portal.
So,
So please
sir,
hold on, sir.
please, sir, please, I have another meeting, sir, with professor. Professor is in USA, sir.
You can do one thing. Please, now you can exit and please rejoin. Maybe hard to 2 to 3 minutes. Then you can close.
So at what time you take that?
7:30. 7:30, sir.
That one is six.
సార్ సార్ అదే సార్ నాకు టెస్ట్ లింక్ కనబడట్లేదు సార్ అసలు అక్కడ అసెస్మెంట్ లో
Sir.
assessment. When I checked in assessment, there is no test link for this.
No, sir. Already people are taking the test and they have submitted the.
Sir, that time I'm showing that assessment.
But it's not appearing for me, sir. It's not. Sir, my attendance also very poor, sir. I mean, it was shown as 3 absents. Actually, I came regularly. I attended all the sessions, but it was shown three absents for my.
Sir, please let me verify once. I'll get back to you.
Yeah. Excuse me, sir. Am I audible, sir?
Sir Chittaranjan sir, please tell me.
Sir, can I leave and again can I join at 7:30, sir?
Yeah, sir, please.
Okay, sir.
Sir, have done exam, huh? Because you have attended all the thing, all the days you have attended, na. Please, once again, please verify once again. Is it so? Okay, okay. Okay, sir.
We will start at 7:30, right, sir? Hello.
Yes, sir. Yes, sir.
Valedictory function will start at 7:30, right, sir?
Yes, sir. Yes, sir.
Okay, sir. Shall I leave now and join at 7:30, sir? Once again?
Yes, sir. Yeah.
Okay, I have
Please, sir.
submitted the test as well as feedback, sir. Thank you.
Okay, sir. Thank you, sir.
Okay.
Please join at
Yes.
7:30, sir.
Yes, sir. Yes, sir. Sure.
Good evening, participants. Welcome to the valedictory session. I hope every participant enjoyed from past 6 days about different sessions which were delivered by industrial experts, academic experts, and overseas experts. And I request all the participants to share their valuable feedback, suggestions, and any improvements or any comments connected to the 6 days FDP program. So once again, I would like to request my dear participants, if you would like to give any suggestions, comments, or whatever it may be, we are in a position to improve in our direction. So please share your opinions. You can unmute your mic and you can express your feeling regarding the 6 days of FDP program. And many participants personally as well as in our WhatsApp group, they thank the coordinators for organizing this kind of workshops and for bringing different experts from industry and academics. So I would like to request one thing to those participants: you please express the same feeling in front of other members as well by using this platform.
Yeah, good evening to all.
Murthy sir, please.
Yeah. Really, it's a well-organized program. Whoever working in this particular area, maybe in my opinion, most of the doubts are clarified for them and most suggestions to improve their work. They got that particular information, I think so. Even when we have seen the persons from IITs, from other colleges, industries, they have just given, they are ready for the collaborative work also, and they have extended their hand. So certainly this is very, very good platform and well organized workshop in my opinion. Really very useful.
Thank you very much, sir.
Sir, good evening, sir.
Sir, good evening.
Sir, I am Bagram from mechanical, sir, from Tirupati, sir. I learn much more of the things from your workshop, sir. It is organized, sir. So, 13 sessions are totally very useful for the engineering applications for the mechanical, especially for the biomedical things, sir. So I enjoy for your experiments, sir. Also for the great for the everyone, sir. I thankful for every organizer, sir, especially for the you and the remaining persons, sir. Thank you, sir. Thank you very much for giving for the opportunity.
Thank you very much for your valuable feedback, sir.
Okay, sir. Thank you, sir. Thank you.
And any other suggestions, comments, improvements of the organized program?
Sir, myself Raghavendra, sir. I'm sir. Actually, we should appreciate your efforts, sir. Like bringing many faculty members or else startup persons and NCAM persons to this platform. So there might be a lot of efforts you might have done, sir. Like a lot of thought process, lot of background efforts. We could feel that work you have done. At the same time, when the AICT schedule also you have managed very well, sir, to bring back the program again on the track. So we should really, we are grateful and thankful to you, sir. Both of you, you have very well coordinated and cooperated among yourselves, and you have shown utmost careful, whenever we are asking a doubts, you are unmuting your mics, or like regarding many things. We should appreciate your efforts, sir. Thank you very much, sir. Thank you.
So thank you very much for your suggestion, sir. You have seen one side of the coin only, but there is other side of the coin. So that's nothing but our department as well as our institute, sir. So at front side of the coin, you can see only both of us, me and Ajay Kumar sir. But back side, there is a huge effort from our head of the department, faculty members. I mean, our department faculty members, management, principal, and every deans and each and every faculty member of the institute supported us a lot to organize this program, sir.
Okay. So we should we are thankful to them as well, and convey our thanks also, sir. Thank you, sir.
Mm. And Kaja Gulam Hussain, sir, are you there?
Venkatesh, sir.
Can you share your valuable feedback towards the 6 days program, sir? Because in the group, you appreciated a lot, but if you express the same feelings in this platform, it will be more beneficial to us, sir.
Venkatesh, sir, shall we start the
Uh,
valedictory session?
okay, I'm sorry.
Uh,
Okay, sir, Ajay, sir.
Dear participants, I welcome you all to the valedictory function and the closing remarks of the 1 week ATAL sponsored faculty development program titled Advanced Biomaterials for Orthopedic and Tissue Engineering Applications. Now, I request our FDP convener, Dr. A. Hemant Kumar Garu, Professor and HOD, to address to the participants. Hemant sir, please unmute yourself and address the gathering, sir. I request all the participants to please switch on the video for a while for taking the close snapshots.
Hello.
Sir,
Hello.
audible, sir.
Yes,
Is
sir.
it
Audible,
to
audible.
all? Yeah, good evening
Yeah,
to you,
audible.
all the
Please go ahead.
participants. I hope you enjoyed the faculty development program for the 6 days. I think you'll learn many concepts on 3D printing. And I wish you all the best for your bright future. Thank you for giving this opportunity to Ajay and then we see Venkatesh.
Thank you, sir. I request the participants please share your valuable feedback. I request the participants, please switch on the video for closing remarks. Let me give the vote of thanks. A warm good evening to everyone here. It is with a great honor and immense satisfaction that we conclude this 6-day sponsored faculty development program on advanced biomaterials for orthopedic and tissue engineering applications, hosted by Department of Mechanical Engineering, ANNAMACHARYA Institute of Technology and Sciences, Rajampet. Over the past 1 week, we have had the privilege of engaging with some of the most distinguished experts in the field. Through insightful lectures and interactive sessions, we explored cutting edge advancements in biomaterials and surface engineering and 3D printing, nanotechnology, tissue engineering, and their applications in orthopedic and medical sciences. This FTP has been a valuable platform for knowledge sharing, networking, and collaboration. It has provided all participants, including faculty members, research scholars, an opportunity to broaden their perspectives and enhance their understanding of the latest trends in biomaterials research and development, and even in the tissue engineering research also. I would like to extend my deepest gratitude to our esteemed resource persons who generously shared their expertise and experiences. By call, the first name, Mr. Rajkumar Ukuturi, founder of Makua Technologies. I would like to thank you, sir. Mr. Manish Amin, the CEO of Away Biosciences. I would like to thank you, sir. Chaitanya Vinay, University of New Orleans, France. I would like to thank you, sir. Dr. Mamila Ravishankar, Professor and Head the Department of Mechanical Engineering, IIT Tirupati. I would like to thank you, sir. Next, Dr. Revat Vyas, the dental surgeon. Doctor, I would like to thank you, sir. Chandra Babu, a research scientist from China. I would like to thank you, sir. Sumant Bhattaria, CEO of Alpha Tech Systems, and Krant Reddy, the director of Susan 3D Tech from an industry. And I would like to thank Dr. Reshma Jolly, senior research assistant of CSIR NPL New Delhi. And I would like to thank Dr. Sreekanth Dondapati, professor of School of Mechanical Engineering, VIT Chennai. And I would like to thank Mr. Rakesh and Piyush Padmanabhan, the CEO of Next Big Innovations Lab. And I would like to thank the co-coordinator, Mr. V. Venkatesh, for handling one particular session because of last minute health issues of a speaker from national level. I would also like to express our heartfelt appreciation to our respected management, Dr. C. Gangareddy Garu and Dr. C. L. Reddy Garu, Dr. C. Ramchandra Reddy Garu, and the Executive Director, Sri Abhishek Reddy Garu. And I would like to thank the General Chair for the FDP and also the Principal, Dr. SMB Narayana Garu, and the convener of the FDP, Dr. Hemant Kumar Garu. And I would like to thank our dedicated organizing team and the coordinators, supporting members, and the faculty members of the Department of Mechanical Engineering, ANNAMACHARYA Institute of Technology and Sciences. And I would like to thank the participants for your enthusiasm and engagement have been truly commendable. Your active participation and thought-provoking questions and collaborative spirit and discussions have made this program more enriching for everyone. We hope you found this experience insightful and that it will positively impact your teaching, research, and professional endeavors. As we conclude, let us take forward the knowledge gained here and strive to implement it in our respective fields, pushing the boundaries of research and innovation. We encourage you to stay connected, continue learning, and explore new collaborations in the field of biomaterials and tissue engineering. Once again, I thank you all for being part of this wonderful journey, and we wish you success in your future endeavors and look forward to meeting again in future academic and research engagements. Wishing you all the very best. Thank you.
Thank you, sir.
Thank you all. Sir, within a couple of days, whatever I have to do from coordinator end, I will work on it, sir. I will try to make it as early as possible so that you can download the certificates from by logging into the ATAL portal. Thank you all. Thank you, sir.